Hello everyone, let's get started with our next lecture. So in this lecture, we'll be interfacing a push button, talking about it, what it is, and interfacing it with Arduino Uno. So before we start that, I would like to just tell you that you might be noticing that we're spending too much time on all these really elementary electronic concepts, and that is because it is very important for you to understand and really learn about the programs and all the circuit diagrams as best as you can, so that when we move on to further projects where we're using relays or many peripheral attachments, it will be quite easier for you to comprehend what we're talking about, and you yourself will be able to write the code and maybe envision and imagine better. So without further ado, let's get started with our lecture. So first of all, I'd like to tell you what a push button is. So as you see on the leftmost side of your screen, this is what a push button looks like, and it is used for providing digital input signal to Arduino. So it's used for providing ones and zeros to the Arduino or any other programmable board that is connected to it, and it's sort of like the conventional switch, but it is different, and let me explain it to you how. So on the right side, you can see two images which show the internal schematics of the push button. So when it is in the release state, that means when it is not pressed, the two pairs of connections are made. So the 1 and 2 and 3 and 4 are internally connected, so they are common. So in the press state, when you actually press the push button, what exactly happens is that 1 and 3 get common and 2 and 4 get common. So all the four terminals get connected to one another and the current flows through the circuit. So we're going to use the digital read function in the Arduino IDE and program it to whatever our application requires. So right now we're in the Tinkercad workspace, and let me just drag in all the components. So we'll be needing an Arduino Uno. So let's search for that, and let's drag this into the workspace. We'll also be needing a push button. So this is what a push button looks like, and we'll also be needing a resistor. So the resistor here will be of resistance 10K. Let's just do that. So we're using a resistor so that when we actually connect it to the pin 6, when the current flows towards the pin 6, it's not that high, so that the Arduino is not damaged. So let me just show you how the connection will look like. So we're actually putting this in active low configuration, which means that when the push button is not pressed, it is initially high, and whenever it is pressed, the state of pin 6 where we'll be connecting the push button, it will be low. That is active low configuration. So let me just show you what the circuit will be looking like. And let's just ground this. We will also need another wire to pin 6. Yes. So let me just clean these wires a bit so that we're able to understand better. And a cleaner circuit is something that is always welcome. So let me just do that real quick. So one more thing that will be changing the colors of these wires. So as we're taking a wire from 5 volt, that will be red, and let's just change the color over here. Then we have a wire going to the ground, so that will be black, and then this is a signal wire. So let's just leave this as perhaps blue, and we can make this black as well. Yes. So what is it that the circuit is actually doing? So we're drawing current from the 5 volt pin on the Arduino Uno. We are passing it through a resistor, and then we're taking it all the way to pin 6. So assuming that the push button is in the release state, so the connection between 5 volt and ground is not made. So all the current is directly going to the pin 6. And through the digital read function that we just talked about, pin 6 will read it as high. So that is how it is initially high. That is the active low configuration. And once the push button is pressed, which means that 1 and 3 and 2 and 4 are common, which means all the 4 terminals are common, which means that the current will flow from 5 volt directly to ground, which means that there will be no voltage on pin 6 of the Arduino. So it will show as low. So what is the objective of the program that we are going to write? What is the objective of the circuit diagram? We want that as soon as the push button is pressed, the onboard LED turns on. As I explained the circuit diagram to you, let's actually talk about the program in a very systematic manner as we've been doing so far. So let's look at the flowchart first. So as you can see here, this is the flowchart. So let me just repeat once what exactly are we doing here. So we want that every time the push button is pressed, the LED, the onboard LED turns on. So that is why in the setup function we're declaring pin 13, where the onboard LED is connected in the Arduino Uno board as the output pin. Pin 6 is the input pin. This is from where we are actually getting the state of the pin, and through that we are determining whether the push button is pressed or not. So according to the circuit diagram that we just made and discussed, whenever the push button is pressed, pin 6 will be low. So we'll be talking that in the next step as well. So we are setting the default status of pin 13 as low, which means that we're turning the LED, onboard LED off at the start of the code, and conventionally this is off, but it's just we're adding it over. So let's see what is actually happening in the loop function. So as you might have guessed, we are testing the state of pin 6 again and again to determine whether the push button has been pressed or not. So assuming that the push button is pressed, what will happen? All the 4 terminals of the push button will be common. The current will directly flow to the ground, and on pin 6 we will read as a state low. So when we ask, okay, check whether it is low, if yes, turn on the onboard LED. That is exactly what we want, right? Once the push button is pressed, we want that the onboard LED turns on. So that is what the flowchart says, and that is what our program needs to do. And yes, if you do not press the push button, that means that we'll get a high state and we'll program it to turn off the onboard LED. So we're actually repeating this loop function and again, and that is what all these arrows and circle mean. So let's actually write this code down and simulate it in Tinkercad. So as you can see, we're back in a Tinkercad workspace, and let's go to the code section where we'll actually write the code for this program that we just discussed, the flowchart that we just discussed. So first of all, we want the pin mode 13 to be the output, as we are going to turn on the onboard LED. And now we want that we are actually testing the state of pin 6. So we'll be taking that as input and getting zeros and ones, and that will mean that the push button is pressed on. So let's go pin mode. Remember that M is always capital here. The syntax is somewhat really important, because if that's not correct, the code will not work. We're also turning the digital, the onboard LED, as low, so that it is off in the initial state. Next, in the while loop, as we discussed, we're checking the state of pin 6 again and again. So in order to do this, we'll be creating an integer variable. Let's name it as var, and what var will store is the state of digital pin 6. So let's write var is equal to digital read. That is the function that we just talked about. So digital read is basically somewhat like digital write, and instead of giving the output, we are actually reading the input that is being given to us using the push button. So digital read 6, where the wire is attached, where the push button, the whole push button interfacing is attached. So where is equal to digital read 6. Now we are back to an if and else statement, where if the push button is pressed, which means that the state of pin 6 will be low, as we discussed with the circuit diagram and in the flowchart as well. We have to turn the LED on. So that is what we do. And if it is not pressed, which means that we'll be getting a high as a state of pin 6, which means that we'll be turning the LED off. So let me just write that if bracket var is equal to, that is just an operator over here, is equal to 0, which means that it is low. We want to turn the LED on, right? So digital, we can always do this, write all this code in the Arduino IDE, but I feel that if you're just going to use a Tinkercad simulation, might as well write this code here as well. So digital write 13 as I semicolon. Do not forget the semicolon, because it's really important. And then we give an else statement, where we say that, okay, else if this is not the case and we're actually getting a high on pin 6, which means that the push button is not pressed, we write digital write 13 low. So I really feel confident with our code now, and we just have to add one more curly bracket to complete that set of code. And let's actually start the simulation and see what it looks like. So let me start the simulation over here. And so according to our code, once we press the push button, we will see that the onboard LED is on. So let's see that. As you can see, the onboard LED turns on. So let me just give you a zoomed in look. So as I press the push button, the onboard LED turns on. So with this, we come to the end of this lecture, where we've learned what a push button is. It's interfacing with the Arduino Uno. And let's move on to the real life demonstration. So one more thing, I'd like to reiterate the fact that I said in the starting of this lecture, that you really have to try your best to understand all these programs, the circuit diagram, the code, and really run these simulations on your own. So that will just help you build your foundation better. And as we move on, when we use different kind of sensors and more peripherals get attached, you really feel that with your core foundation, if that's very good, you'll be able to program well and understand what is going on very well.